This is my video on the numerical model. So this is an introduction to it. A numerical model is a form of quantitative analysis, meaning it gives you numerical data which can be used to analyse technique and performance of sport, which in turn can then be used to improve performance. Numerical models can be created from literature such as a manual for the specific sport, online through sports-based websites or videos, and also elite athletes and their techniques. They also use kinematics and kinetics as well. A kinematic is the study of motion of a body or object, so effectively any changes in position. They therefore look at different types of motion: linear, which is movement in a straight line; curvilinear, movement on a curved line; angular motion, motion around an axis; and general motion, which is a combination of both linear and angular. Kinetics involve looking at all the forces involved during the movement of the body or object. Like with kinematics, they look at linear kinetics and angular kinetics. Linear look at forces, weight, mass, and gravity, whereas angular kinetics look at moments in movement and levers. So now we're going to look at force in general and the effects that it can have. Any type of motion is created by a force, and a force is a push. For example, passing the ball in basketball, or a pull, which could be trying to grab the ball of another player on the object or body. The motion is created by a force being exerted as it acts on the object. They can be of different sizes and also in different directions. This makes a force a vector, as vectors relate to the magnitude, also known as size, and direction. There also doesn't have to be direct contact for a force to have an effect on the object, for example, air resistance or friction. As forces relate to direction, there are different directional forces. There are vertical forces, such as air resistance, so that could be the air acting against the ball as it is in the air, and also horizontal forces, which could be drag. For example, in swimming, there's drag working against the performer as they're trying to propel themselves through the water. Both of those are external forces as they are outside the body. Others of these could be gravity, which is the force with which the Earth or other large object attracts another object, or friction, which is the force exerted by a surface as an object moves across it. But forces can also be internal, such as muscle contractions. Arrows are also used to show the direction a force is being applied and how large it is, so the bigger the arrow, the bigger the force. When there are two forces acting against each other, these can be subtracted from each other to produce a net force in the direction of the larger force. Or if there are two forces acting in the same direction, they can be added to create a larger net force. However, if the forces are equal in either direction, they will produce a net force of 0, during which the objects will remain stationary or at a constant velocity. But if the forces are unbalanced, the objects will move with acceleration or deceleration in the direction of the bigger force. Finally, force itself can have 5 different effects on objects. The first is which it can make an object go from rest to motion, meaning it gives the object momentum. The second is it can change the direction of an object by acting in a stronger manner on a different part of the object. The third effect is acceleration, simply meaning it increases the velocity of the moving object. The fourth effect is deceleration, being the opposite of acceleration. And finally, the fifth effect is change in shape. For example, a player receiving a basketball would change the shape of their hands than where they were before they received the ball. We'll now look at different types of motion. So the first type of motion is linear motion. This refers to a motion where all of the body moving in where part of the body is moving in a straight line or a curved line, which, for example, could be in running as the torso stays in a straight line. The second motion is angular, which involves when a body or body part moves in a circle around an axis. So in the case of running, that could be the arms or the legs. And the third type is general motion, which involves a combination of both these. So running in general is general motion, but different parts of it are different types of motion. We will now look at Newton's laws. Newton's first law is called inertia. Its main idea is that any person or object will stay in its constant motion unless an external force acts upon it to change this motion. The force acting upon the person or object to change its constant state has to be unbalanced, meaning there will be acceleration, and this is what changes the motion. For example, in basketball, an example of inertia in motion would be if the ball was in the air going towards the basket and it bounced off the backboard. that would be the external force as it changes its motion in terms of velocity. Or an example of inertia with no motion would be in the block position for box out and rebound, and the player they are marking has a bigger mass than them and pushed from behind, and they would move forward, changing the constant motion from stationary to moving forwards. The second law is acceleration. This law relates to the rate of change in momentum, effectively meaning how big or small the motion is. The proportion of the size of the force applied and the direction in which it is applied affect the acceleration of an object. The object's acceleration is directly proportional to the magnitude of the net force and in the same direction as this net force, but it's inversely proportional to the mass of the object. Again, for there to be acceleration, there must be an unbalanced force. The acceleration happens in the direction of the larger force. For example, in basketball, when passing the ball, this is an example of acceleration. The ball moves forward out of the player's hands as the force the player is pushing on the ball, and it's larger than the force of air resistance acting against it, and is also larger than the inertial mass of the ball. You can calculate the acceleration of the object by dividing the force applied by the mass of whatever is accelerating. The third and final law is action-reaction, meaning that for every action that takes place, there's an equal or opposite reaction. Meaning, in a sense, there's a reactive force as the result of another action being performed. So, for example, bounce pass, the player pushes the ball down into the floor. The reaction is the ball bouncing back up, and then it'll be stopped by being caught by another player. We'll now look at momentum. Momentum is how much motion a moving object possesses due to its mass and how much velocity it has. Velocity refers to the speed of something travelling in a given direction, and you calculate momentum by multiplying the object's mass in kilograms and its velocity in meters per second. For example, a player of 80 kilograms sprinting up the court at 10 meters a second, so the momentum is therefore 800 kilograms per meters per second. Now look at impulse, which is related. Impulse is effectively another way of describing force in a way, but it relates to how much time a force is applied to the object or body, which in turn relates to changes in momentum, which are effectively a consequence of how much time a force is applied to it. So therefore, impulse is calculating by multiplying force by time. So for example, a basketball player applies 30 newtons of force to the ball for 1 second, meaning the impulse is 30 newtons a second. In order for there to be a change in momentum, either the mass or velocity of the force or time applied have to change, and when this occurs, that is impulse. We'll now look at stability. So in order to be able to analyse the movement and force of our vertical jumps, we used stability is defined as resistance to both linear and angular acceleration, or resistance to disruption of equilibrium, which effectively means that an athlete is able to stand in a position and not move or lose their balance. So every person or object has a centre of mass, and the centre of mass is effectively the point where all forces are balanced. So it's the centre point in an object's mass. A person's centre of mass can change depending on the position they are in. As you can see in the image, just when a player is shooting a basket, their centre of mass changes multiple times through this motion. And it can also be different in men and women, as it's related to where the most weight is carried. So in women, it tends to be a bit lower down as they carry more weight in their legs and waist area. We also have a base of support, which is the area under an object, including all the points of contact the object has to the supporting surface. So in a human's case, this could be their feet or hands or any part of their body which is holding them up. As you can see from the image, the arrow represents this player's current base of support in the blocking position for a box out and rebound. So their base of support is between either of their feet. Also have a line of gravity. This is the line that runs down from the centre of mass. If a person's line of gravity is in the centre of the base of support, this and therefore their centre of mass, this would also be in the middle of the base of support, and this is when a person will be at their highest stability, like in that picture. Stability can be increased or decreased. This is done by making the base of support smaller or larger. The larger the base of support is, the more stable a player is. like in the block position of a box out and rebound. But if the base of support is small, this makes the player less stable. For example, if you're balancing on one foot, you're of a low stability. We'll now look at the method. So in order to be able to analyse the movement and force of our vertical jumps, we used force plates to measure our ground reaction force and then took some footage and images to help further the analysis. By filming the movement, this allows us to look at technique to then be able to further their technique and improve their performance. But in order to effectively capture data, there are many things the observers have to be cautious about. Before any of this can actually take place, the participants should be given a medical questionnaire to establish any possible risks, and the informed consent of the participant also should be gained. A structured warm-up should then be performed by all participants in the same way and the same structure, and the protocol of their task should then be explained so they are clear on the task at hand. Both the warm-up and the protocol must be very standardised so that each performer does it in exactly the same way, giving the experiment higher reliability. As if it's repeated, the same or similar results should be found as the same technique was used. The participants should also be allowed to have a few familiarisation jumps before completing the ones that will be analysed. So that they can also get used to the technique and help ensure that it is further standardised. The angle can be standardised by measuring the angle needed and then holding a stick behind their legs, so when they bend down and feel the stick on the back of their knees, they know to jump up. However, when we did it, we didn't do this. We just attempted to measure the angle with a gynometer and then tried to remember the angle we were supposed to reach by feel, which may not be as effective and may affect the results. Plates themselves also need to be calibrated to ensure they gave an accurate reading, and also to ensure that if the jump is taking place over more than one plate, that they are in sync with each other to provide as accurate reading as possible. The participants should be standing on the plate when this is done, so they are effectively zero, so the results don't reflect their weight but just show the ground reaction force produced. This could be a downside to the method in that if the calibration isn't done properly, then the results will be inaccurate, affecting the validity of the results. Firstly, in terms of filming or taking images, I'm going to discuss the method and possible obstacles that come with filming. When recording images, they can be recorded in 2D or 3D imaging. Overall, 3D imaging is better as it adds depth to the image, and with certain software you can take a 360 view of the image, which allows you to see all different perspectives and angles. Whereas with a 2D, if you turn it, it becomes flat eventually from the side and doesn't show all possible perspectives. Accurate and easy to analyse data, there are certain settings and features on cameras that can help to achieve this. One thing you need to ensure is that the camera is zoomed in or out enough to ensure that the whole person is in the shot, and therefore you won't miss any important data. Another two things that can affect data collection are the frame rate, which is how many frames it catches a second, and the faster this is, the more movement you will capture, giving you better data collection. And also the shutter speed, the faster the speed, the more images you'll collect, as it will open and close faster between shots. Lighting can also play a role. If it's too dark or there's a shadow over the image, then the perspective won't be as good, making the data harder to analyse as well, and ensuring the camera is in focus is also essential for the same reasons. If you have a slow shutter speed, that can also affect the lighting. The position of the camera is also very important. For example, if it's too far away or too close, you may miss crucial data. But not only that, if it's not in the correct position, then it could cause perspective errors. That's why when setting the camera up, you must ensure it's completely level to where the action you're recording is taking place. As if it's tilted too far one way or another, it could provide inaccurate data. When panning the camera around as well, if you're following a movement, it's important it stays at the same level the whole time, or the images could be inaccurate again. You ensure the level is correct by using a spirit level so you know it's straight. Once you have your data, you can use the software Dartfish to further analyse it, as it allows annotations on images or features such as slow motion. However, this is very expensive, so therefore will not be available to everyone. And finally, all the numerical data is placed into an Excel spreadsheet so it can be seen clearly and then used to make tables or charts to further analyse it and make it more accessible. However, it's a very complicated system. Putting all the data into it from one software, from the force plates into the spreadsheet, can be a very long and complicated process. And without the knowledge or skills of Excel, this process would take a very long time, making it not very accessible to everyone.